Hi, everybody. Welcome to our next installment of our Pandemics and History series. We've been presenting this series for the last month or so, and this will be the fourth installment of this Pandemics and History webinar series. About 3 or 4 weeks ago, Dr. Julie Weisskopf talked with us about the colonial origins of AIDS. After that, Dr. Regina de Aragon spoke with us about the experience of the bubonic plague in the 14th century, followed by Dr. Goldman, who shared with us stories about the Athenian plague of the 5th century BC. Today, I'm delighted to present another installment in our series, and today our speaker will be Dr. Veta Schlimgen.
Thanks for that introduction, Kevin, and welcome everyone. I want to add that I'm a historian of the modern United States. So I do research and teach on race and ethnicity, on women and law and citizenship, and on the US relationship with the rest of the world, particularly in the Pacific. Again, I want to welcome you, and I invite you today to work with me through a comparison of the 1918 flu pandemic and the 2020 coronavirus pandemic. As a disclaimer, I mentioned that I'm a US historian, and so I was familiar with the 1918 flu, but like all of you, I've recently begun to dig into the details. And what I discovered as I did this is that there are some astonishing similarities and some very important differences between the two pandemics on a global scale and within the United States. So here I want to acknowledge that the flu was a global event. But today I'll ask you to focus with me mostly on the United States, and we absolutely will reference the rest of the world. Doing so, I want to point out that this analysis is mine, and it doesn't reflect the views of my department or of Gonzaga. The first thing that drew my attention to this was an interview that I heard back in February, which seems like eons ago, with a science reporter who is a Pulitzer Prize winner. This is a kind of person who goes into epidemics to report on them. And as the pandemic crashed into the United States, she said that we will find out what is the mettle of Americans. And this caught my attention. Up to this point, much of the news I had encountered focused on viruses, their infection rates, how they spread, and how we contract them. But Garrett's suggestion, that's this reporter, she spoke to the relationship between biology and society. I liked her framing. And so that is my focus for today. How did the 1918 flu pandemic test the social fabric of the United States? And how does that catastrophic event compare to the US in the 2020? So we'll focus on a comparison of infection, the preparation of both societies, the national responses, our social responses, and our communities. I think that what we find here is incredible similarities, but also the ways that it tested the American social fabric and exposed definite problems. Along the way, we're going to consult experts, which is what I did, and refresh ourselves about the basics. So to start, we'll go to the groundwork and gain a better appreciation for the 1918 flu pandemic. What became a global 2-year epidemic began in the winter of 1918 in rural Kansas. In January of that year, a doctor in Haskell County, which is in the little red square there, he alerted U.S. Public Health Service about an unprecedented uptick in residents who were seriously ill. Some of them had even developed pneumonia. A few Haskell County residents left the county and they went to the red dot there, Camp Funston, Fort Riley, Kansas. And they did this, of course, because they were young men. They were new recruits into the US military, and they were going to join the fighting in Europe during World War I. So soldiers at Camp Funston fell ill, and the war continued. And because the war continued, that meant that soldiers continued to move. So the flu circulated from Kansas to camps in Georgia and in the Carolinas, and from there it went to the front lines in Europe. This was the first wave of the 1918 flu, from January to about June. In this wave, the infection was disarming for those who contracted it, but it was mild compared to what came next. In the first wave, the mortality rate was about 0.1%. It was in the spring and summer of 1918 when Spanish newspapers reported on this flu. It was something that other governments in Europe had refused to do. In fact, they suppressed newspaper reports about the flu because they thought it would impact the war effort. So this is how the 1918 flu became known as the Spanish flu, because it was the first nation to report. Many people thought the flu originated in Spain, which it hadn't. Sometime in late August, and somewhere probably in northwestern France, the flu virus may have changed. And the outcome was that the flu came back more virulent and deadly. It moved from France to West Africa and then to North Africa. Sorry, and back to North America. This happened from August to December of 1918. There was a little bit of a brief spell of a break in the epidemic, but it came back in a third wave in February of 1919 and continued to infect people throughout the world through November of 1919, when world leaders went to France to negotiate the end of the First World War. And it's at this point that President Wilson and other global leaders who were in Paris also fell ill with this flu, this 1919 flu. So this basic information confronted me with a lot of questions about viruses particularly. Lucky for me, I'm surrounded by experts. And so I contacted Dr. Christy Andrade in Gonzaga's biology department. She's a virologist, and she provided me with some key details on viruses and what the scientific community knows about the 1918 flu. Here's my full interview with Dr. Christy Andrade in the biology department at Gonzaga University.
So have you seen any images like this? Like, I can read it to you. Like,
yeah, yes,
so
with pneumonia, and
yeah,
not the images, but the reports that most people got pneumonia after getting the flu.
Exactly, and this one says, so it says influenza, frequently complicated with pneumonia, is prevalent at this time throughout America. This theater is cooperating with the Department of Health. You must do the same. If you have a cold and are coughing and sneezing, do not enter this theater. Go home and go to bed until you are well. Coughing, sneezing, or spitting will not be permitted in the theater. In case you must cough or sneeze, do it in your own handkerchief. And if the coughing or sneezing persists, leave the theater at once. Anyway, I thought it was kind of interesting because it's kind of similar to what we're doing today, I can take a picture and send it to you if you want. The other thing I liked from this book is in the very beginning of the chapter, she explains where the word influenza comes from.
Oh, she does.
Have you done this yet?
No, what's the etymology?
Okay, so I'm just going to read. So it says the word influenza stems from the 15th century Italian word influentia, meaning influence, from the belief that epidemics caused by the virus were attributable to the influence of the stars.
Oh, wow.
Isn't that interesting?
Our pandemic is in the stars.
It is. Well, coronavirus is like the corona of the sun, right? So it's celestial also. So, but
it makes it out to be far more beautiful than it is on the ground here.
I mean, viruses can be beautiful, right? But disease is certainly not. So how do you want to do it? I break it out question by question, or?
I wondered if there were questions that you liked on my list, and if there's one that you'd like to start with, because I liked the first question as can you remind us about the difference? But if there's another question that you like better, we could start there.
I think just going in order works, because you can always edit it later, right?
Yeah.
And then and when I was answering some, I was like, oh wait, I should have mentioned something earlier. So we'll see how it goes.
Yeah.
I also didn't know what level of science techie speak to do, so I'm trying to make it layman, but not like totally leave out a lot of content. So if
that sounds good, because
okay.
I was thinking maybe like what you would offer to an intro class, because the goal of these History Matters events is to invite students, and so that's our audience. So we're expecting people who have a little bit of background and know-how, okay. But I have noticed in the previous History Matters that we've gotten a lot more like GU adult. I mean, not that our students aren't adults, but faculty and staff.
Yeah. Past that point of 25 where their brains are fully formed.
Exactly. Yeah. So, fully formed brain crowd.
There we go. Yeah. I know that crowd. Yeah. Excellent. All right. So So I guess, do you want to ask the questions or should I?
Yeah, can I ask you the questions?
Yes. Let's do that.
Okay. So I want to start with the question that I asked you. What is the difference between a bacterial infection and a virus? If you can help remind me.
Sure. So bacteria are actually cells. They're single-celled organisms, and they're called prokaryotes. So they're similar to like an animal cell because they have ribosomes and they have a DNA genome, but they have some major differences from an animal cell in that they have like a cell wall that's got this special chemical in it called peptidoglycan, and they also lack a nucleus, and they don't have some of the organelles that you would have in an animal cell. Of interest, that peptidoglycan and some of the special features of bacteria are what antibiotics target. So that's why you can take an antibiotic and it would kill a bacterial cell, but not you, right?
Oh, okay.
Yeah. Viruses aren't cells. They're not even living, and I'll get into that in the next question. One of my former students actually gave a really visual image that they're almost like a crunchy, like an M&M with like a crunchy protein coating and then a genome center. So what a virus is it's just this protein coat, and it's like a shell. And sometimes it might have like a lipid membrane around it, but inside there's just a genome. So it's just RNA or DNA. And sometimes they have enzymes that they need to take with them to start an infection when they get to a cell. But that's all they are. When we're thinking historically, before we knew the difference between viruses and bacteria, what people would do is they would actually filter their infectious agent. So bacteria would get trapped in a filter, and therefore the liquid that passed through a filter wouldn't contain bacteria. Mm-hmm. But you could still inject this filtered agent and it would cause disease. And so viruses were found to be filterable and smaller than bacteria, right? And so that's how people started to parse out the difference between bacteria and viruses.
I wondered about that because the 1918 flu, they thought it was a bacterial infection and they were trying to treat the bacteria. And it wasn't until 1933 that they discovered, oh, that was actually a virus. So all of the things we were doing were ineffective.
Exactly.
So then, can I ask a follow-up question? Sure. About how then, with a bacterial infection, then you get the bacteria in the organism. That's what makes it sick. With the virus then, does it I guess, I don't have the right technical term, but glom onto cells in order to create an infection?
So viruses are what we call an obligate intracellular pathogen. They need a cell or they're just, this inanimate thing. But a virus would attach to a cell through like a different cell receptor. And then basically the name of the game with a virus is to get its genome in the cell and start making copies of virus.
Within that cell that it has.
Exactly, within the cell. Some bacteria also need a cell, like chlamydia needs a cell to replicate, but then many bacteria don't. So if you're coming into contact with like E. coli, right, or cholera, that would be bacteria that would travel through your intestinal, travel through your gut basically and attach to cells there. But they're not necessarily having to get into the cell to do the damage. They're able to have their own replication cycle outside. And in the case of like cholera, it would be a toxin that the bacteria secrete that is doing the pathology to your intestines.
Okay.
Yeah.
Thanks.
Yeah.
So that clears up my second question for you, which is how does a virus live and die? But it doesn't really have a life cycle because you noted that it's not a cell on its own, or does it?
Well, okay. So this idea of if a virus is alive or a living thing or not is hotly debated. And people will spend days talking about it. They don't fully fulfill all the requirements of life, like they're not metabolically active on their own. They require a cell to reproduce, but there are exceptions to every rule. And so some people think that they're close enough to life to consider living, and other people say, no, they don't fit the rules, so they're not. But what gets really confusing is that despite that, we still use language as if viruses are alive. So, we still say we grow viruses, or they have a life cycle, or they survive or not, so we still use all the words as if they were living.
Okay.
Yeah.
So then, related to that question about the virus, and it clearly needs a cell, so it needs a host in order to maintain and reproduce.
Yes.
Does that help us then? Can you help us understand better how a vaccine helps to a viral vaccine interrupts that process, or where exactly it works? Or maybe it's different for every virus.
So it's not so much the life cycle that we're trying to interrupt with a vaccine. If we had an antiviral drug, that would be trying to interrupt the virus at some point in its life cycle or replication cycle. What a vaccine is trying to do is prevent infection. So a vaccine, for the case of a virus, is basically going to mimic some aspect of that virus that's immunogenic, meaning it's going to get a response by the immune system of the host. And so, so basically we need to figure out, if we're designing a vaccine, we need to figure out what is immunogenic, what's going to get the strongest response from the immune system. And normally for a really good vaccine, you want something that's going to hit the humoral and the cell mediated, so antibodies and T cells.
Okay.
And so you'd be getting both of those. So the idea then would be that when, if the body is primed and it knows what agent it's trying to detect, like through this vaccine, then if you're challenged with the actual virus, the body already has antibodies and T cells that can recognize that antigen. And so it can basically attack faster. And so, like, for instance, with antibodies, it's pretty easy to visualize, because what we're trying to do is get a neutralizing antibody response. So basically, if you have that virus, then it would get coated with antibody, and then cells would recognize this coated thing and destroy it.
Wow.
So yeah, so that's how vaccines are trying to work, is that basically it's like a hunt and destroy kind of thing. So when you actually get the pathogen, your body can defend itself.
Yeah, that's pretty cool. Okay. I wanted to ask you a question about viral mutation, because with the 1918 flu, there is still a little debate. And if you know more about this, tell me, that the histories I've read said the 1918 flu, it wasn't a zoonotic. So it didn't come from animals, that currently the scholarship says that it was a mutation of an existing human virus. But then so this is in early 1918 that it first appeared, and it was much more infectious than any other viruses in the community at the time. But then about 6 months later, the virus mutated again and became more deadly. So people were getting it and dying at a higher rate. So can you tell me about mutations in viruses? How common is it?
So, okay. So first of all, I read what you wrote about the 6-month thing, and I was like, wait, I haven't actually heard that before.
Okay.
Because there's only 5, to my knowledge, there's only like 5 samples that we have of the actual virus from that time period.
Okay.
So, so let me talk about virus mutation first, and then I'll talk about the pandemic a little bit, at least my understanding of it. And my background's actually vector-borne disease, so I'm a person that studied like West Nile virus, so I'm aware of flu, but my specialty is vector-borne diseases. So I'm going to do my best. All right. So meaning that like the very nitty-gritty history of these strains and everything isn't something I've necessarily studied, but so viruses constantly mutating. Every single time that they replicate, you would expect to get a mistake in there. And most of these mutations aren't going to change the fitness of the virus. So they're not going to have a big effect. It's just, just part of basically the milieu of viruses. So a lot of viruses exist as like a quasi-species, meaning that there's just so much diversity that is all mixed into this thing. Okay? And some of the mutations that are going to happen will actually cause the virus to lose fitness. So it'll be of an advantage to like humans, for instance. This is actually something that we take advantage of in making vaccines. So in the early days of making vaccines, they would take like yellow fever virus as a classic example, passage it in an atypical host, like, like say mice, over and over and over and over again. The virus would adapt to that host. And then it would have certain mutations that in that host might make a difference, but when that virus comes back to humans, it's super attenuated and it's not going to cause disease like it used to.
Wow.
So yeah, so we take advantage of this quite a bit. Potentially, if viruses lose enough fitness, then they're going to kind of peter out and we don't see them anymore. The opposite can be true too, where when, the mutations, especially under certain selective pressures, might cause like an increase in virulence or an increase in pathogenicity. When you think about HIV, and we've got people on highly active antiretroviral therapies, those viruses are under a constant selective pressure because they're replicating and living, so to speak, in a high drug land. And so they're trying to evolve and deal with that and survive that, right? So viruses have to deal with the environment that they're in, and that puts a certain selective pressure on them. The other thing to think about is that viruses have different mutation rates depending on if they're DNA or RNA. The DNA viruses, like they use a DNA polymerase to make a copy of themselves. And DNA polymerases are something that we have in our cells. They tend to have proofreading capabilities. So if there's a mistake, then a DNA polymerase could possibly fix that mistake. So you tend to have much lower error rates in DNA viruses. So their mutation rates would be lower. Okay. But RNA viruses like influenza or the current coronavirus, they don't have any proofreading in their RNA polymerases. And so they have many, many more mistakes. And so you get a higher rate of mutation in them. There's one more thing I want to talk about mutations, and that's where the mutation happens. Okay. So if a mutation happens that changes the protein sequence of the virus, then that's more likely to cause a change in the fitness or the phenotype of the virus. If it happens in one of the proteins that's involved with attachment to a cell, then that can change like the type of host or the cell that the virus can actually get into and infect. And so from the virus's perspective, the things that it needs to overcome are accessing a host cell and then getting its genome in. And so sometimes these mutations might make a virus able to infect a wider host range, right? Or new cells, things like that. So these are things we think about with viruses and mutation.
So then it sounds like mutation, at least mutation that creates greater infection rate, like what I've been reading about the 1918 flu, that's probably not what happened. I mean, what's your impression?
With flu, there's antigenic drift and antigenic shift. And so like the day-to-day mutations that we get cause drift. It's just, we have mutations occurring. And if a mutation occurs that the body can no longer neutralize that virus with its antibody response, then the virus escapes, so to speak. And then you would have, high levels of infection and a virus that people can't really tolerate that well. With antigenic shift, which is getting us into this H1N1 conversation, then you have a new variety of H and N. And so that's going to cause much different things. So there's actually 3 types of influenzas that we recognize currently. There will likely be more, but those are A, B, and C. A and B infect humans. And so type A influenzas are the only ones where we have subtypes of H and N. Okay. And so H stands for hemagglutinin. And what this is it's the protein on the virus that attaches to a chemical called sialic acid. And sialic acids are in the host respiratory system, the cells that we're going to be infecting. And so the hemagglutinin helps attach to that sialic acid, and then that's what allows, attachment to occur. Neuraminidase is what N stands for. And neuraminidase is also found on the outer shell of the virus, but it's an enzyme that's going to cleave sialic acid. So when the new viruses are made and they're trying to leave the cell, neuraminidase is what cleaves the sialic acid and allows the virus to leave. So they're actually like, yin yang of each other. They have opposite functions. Oh, and another thing is when you take Tamiflu for flu infection, it's blocking neuraminidase. So the virus still gets into the cell, it still replicates, but they can't leave that infected cell to go on and infect new cells. So that's the function of Tamiflu.
Okay, that's why it's so popular right now.
It's popular, but it only matters if you have a flu virus with neuraminidase, otherwise. So they have these opposite functions, right? And so H helps with attachment, N helps with release of the new viruses. And the number next to H and N matter. Okay, so there's actually 18 different subtypes of H.
Wow. Okay.
And there's 11 subtypes of N. Different types of animals can be infected with different H's and different N's. So birds are wild because they can be infected by almost any type of H or N.
Okay.
So birds can be infected by types 1 through 16 of H, so H1 through H16, and N1 through N9.
Wow.
Bats have 2 unique H's, 17 and 18, and 2 unique N's, which would be 10 and 11. So you wouldn't hear, so if you have bat influenza, it would be like an H17 and 11 or something like that.
Okay.
So it's important that the birds can be infected by almost any type of flu. Humans can only be infected, to our knowledge, by H1, H2, H3, H5, 7, and 9.
Okay.
And then the N corollary is N1, N2, N3, N7, N9.
Okay.
That's a lot, and I'll try to make it make sense in a minute. So basically, of all the diversity of H's and N's, humans can only be infected with certain ones. Swine, pigs, can also only be infected with certain ones, and they overlap a lot with what humans can be infected with.
Okay.
So that's important because that means that the viruses that infect humans can also infect pigs and birds.
Yeah.
And they can all be of origin of one another. So each influenza would have a combination of H and N, like how you're saying H1N1. And there's only been 4 combinations that have known to circulate in humans to date.
Okay.
So, but that could be because we have limited knowledge of the way distant past, or this could just be fact, right? So H1N1, H1N2,
Okay.
H2N2, and H3N2 are the only combinations that have circulated in humans. Currently, we've got H1N1 and H3N2 circulating in humans.
Okay.
And those are the 2 that are covered in the flu shot every year.
Ah.
The other part of your flu shot is influenza B. So that type that we don't specify the subtype because there aren't subtypes of H1N1 or H's and N's, sorry.
Oh yeah.
And so you also have some influenza B that's covered in your flu shot every year.
Do we know what the coronavirus is in the H and N?
So coronavirus isn't an influenza. So coronaviruses don't have H1N1 designations because it's not an influenza type A.
Oh, is an influenza type B?
No, it's not. It's a completely different family. So kind of like how this is, it's almost on this level. So like how humans and chimpanzees, totally different species, coronavirus and influenza viruses, totally different species.
Wow.
There's some similarities in the cells they infect and that sort of thing, and use of sialic acid, might also be involved, but they're very different otherwise. So.
Oh wow. Okay, so this is really new territory then.
Sort of. I mean, coronaviruses, they were studied in the 1960s a lot. There was a lot of studies where people were interested in kind of squelching the common cold.
Yeah.
And so back in the 60s, there were different groups that would get isolates from people with cold-like symptoms and try to, figure out the virus. And they found coronaviruses, and they called them that because when they looked at them under electron microscopy, they had like, a ring around them that looked like the corona of the sun. So coronavirus, or crown. And they actually did human volunteer studies where they would infect people with those viruses and then see what the symptoms were and compare them to rhinoviruses, which is the other main cause of cold. And after that, coronaviruses weren't super popular until the SARS, SARS, the first outbreak, in 2002, 2003. But flu is just such a big part of our lives that it's something that we've consistently studied for a long time. What's important about flu to realize for the current day is that you will have heard of other combinations. Like some people might be thinking, wait, I've heard of other HN combinations like H5N1 or H7N9. Those are highly pathogenic avian influenzas. So those are H and N types that can infect humans, but we don't really understand if they can then be transmitted human to human very efficiently.
Oh, okay.
There's some evidence that they can, but they have never established, a very sizable amount of infections to then spill out into the general public.
Yeah.
So some people that have been infected with avian influenza directly from, say a chicken or whatever, within their household, they might have infected other people. But yeah, so that's the thing that we need to watch out for is if we start seeing H5N1 circulate or H7N9, then we're in big trouble as far as flu, because when you see, so this gets back to that idea of antigenic shift. So when you see these new combinations of H and N that people have not been exposed to before, we have absolutely no immunological memory to them. And so we have, just like this new coronavirus, we have no immunity that's going to necessarily help us in fighting these viruses. Okay. And the only way you build up immunity is either through getting the virus and getting sick and then building your own immune response, or you can get it passively through breast milk or, a vaccine. Okay.
I wanted to go back to you had briefly referenced what you know about the 1918 flu virus, because I said that I'd read that some mutation made it more infective, and you thought that might not be the case.
Okay, so this gets to where we're going with that question. It's important to recognize that swine and birds and humans can all be infected by the same flus. And what happens is that these viruses jump around to different hosts. And then another fact about influenza I didn't mention is that as a virus, when it travels around, it's got 8 different pieces of genome in it. So a viable flu needs 8 different pieces, and they can all be from different places. And so if say a pig got infected with 2 different strains of flu, then it within that pig, it kind of acts as a mixing vessel. The virus can reassort, and so you get pieces from one origin and pieces from another, and so that helps diversify the virus. And so what likely happened in 1918 was that we have this shift, so that all of a sudden we started seeing H1N1 viruses. That was a combination we hadn't seen before as humans, and so it jumped into the human population. And it was so devastating because we didn't have any built immunity. We hadn't seen this combination before in living memory. There were 3 waves to the pandemic. And so what possibly happened was that in between those different waves, the virus could have jumped back into pigs or back into birds and then mutated or reassorted and then was reintroduced into humans. That would have been happening, but also the virus would have been mutating at the same time. Basically, all that we can do is make conjectures at this point, because we would need to have samples from certain different points of time to actually show genetically that that's true.
So that it is possible that it mutated sometime in 1918, that mutation could have been in humans, but it could have been some mutation that also involved an avian or a swine flu, but that when it infected the human population, that might explain why it seemed to have a higher mortality rate, that this slightly changed virus?
Potentially. So it's kind of like what happened with H1N1 when we saw it in 2009 again.
Yeah.
So there had been H1N1 circulating, since I think the 70s, sort of low level. But then in 2009, we had what's called a quadruple reassortment virus. So it had swine and avian origin, and it had reassorted to combine lots of different pieces 4 times. And so this new combination was exceptionally virulent compared to the virus that we had before.
Okay.
It had jumped to humans directly from swine. And so, and that doesn't happen as often as we get viruses directly from avians. And so, so when the CDC saw that happen, they knew that something different was happening and that we needed to act quickly. So this idea of getting new strain, new combinations of H and N, it's important because when that happens, we have bad flu years because it's new to people. It also happened, 1957 was another banner year for flu. I think there were 70,000 deaths. And I believe the US, don't quote me on that.
So I remember reading something about that.
But that was when H2N2 arrived. And so H1N1 that started in the 1918 pandemic, all of a sudden disappeared, and we started having H2N2 circulating.
Wow.
So that's kind of how that flux and shift happens.
Yeah. So the corollary to this question about mutation is that the waves of this epidemic from the beginning of 1918, it started in January in Kansas, then it moves throughout the world. It comes back in the fall, in October and November, and that's when it seems to infect many more people, the higher mortality rate, and that lasts into like January or February of 1919. And then there's a third wave early in 1919. And so is it possible that each of these waves, it may not have been a mutation, it could have been, but also the fact that, like you mentioned, there's just no human immunity to it. And so that as the virus goes back through the population, it's just hitting a population that has no defense and has no herd immunity.
So it could be that it reassorted and we saw a more virulent version. It could be that some mutation happened, like you were suggesting, or it could be that people weren't previously exposed and then they were this next time.
Okay. Yeah.
It's something we also need to worry about with this coronavirus pandemic currently, because historically coronavirus immunity isn't long-term. It might be, I'm just throwing out a number, let's just say it's for a few months. So if you've already been infected with the coronavirus, then you're only protected for a short term. You could get it again. And so that's why they expect for us to see lots of waves of this virus as new people are getting infected, or people who've already been sick get infected again. They're saying, we'll have a coronavirus vaccine, but the issue with the vaccine is how effective will it be and how long will the protection be, especially when historically coronaviruses don't have very long natural immunity, or we don't have very long natural immunity to them. So is this the kind of vaccine that we'd need every year, like the flu vaccine every 6 months? Or is it going to be something that you get twice, you have the initial, you have a booster or 2, and then you're done? We don't know.
So this is all new territory.
Yes.
Thank you so very much for agreeing to talk with me and give us more insight into viruses. I really, really appreciate it.
Of course. They're fascinating, and there's a wealth of endless things to learn about them.
Yes. Dr. Andrade helped me understand how viruses change, either by shift, drift, or by mutation. After talking with her, I had to rethink what I had learned about the history of the 1918 flu virus, because the scholarship I'd read said, it mutated, it became more virulent. And after talking with her, she said the 1918 flu virus may have mutated. It might have mutated as a human strain. it might have gone into an animal population, like an avian population. It might have mutated in the avian population and then came back to humans, and that's what made it more virulent. It might have just shifted, though, or simply maintained its status, but it had a better population to infect. And so she said, we really don't know, and she emphasized this, what exactly happened, but we do know that starting in about August or September of 1918, this flu came back with a vengeance. Many more people were infected and many more people died. And part of the reason for this is because this was perhaps the first H1N1 flu virus. So humans had no immunities to it. And this is part of the reason it was so infectious and deadly. It had a perfect environment created for it by the movement of people and the concentration of people during the First World War. Experts do know the origin of the coronavirus, of COVID-19. It's a zoonotic, so it's a virus that existed among animals and it had the right factors to infect humans. In this case, virologists think that the virus came from bats, but humans have contracted zoonotic viruses from birds and from swine as well. So now that we have the basics, let's look at the 1918 flu and the 2020 coronavirus in comparison. And the place I'd like to start is with the remarkable similarities in infection. Both pandemics, viruses spread the same way. The 1918 flu spread from one person to another through water vapor. That is, water vapor that contained the virus. It was emitted by talking, sneezing, coughing, but also by touching surfaces where the virus lived and then infecting yourself. Both of these viruses were spread through asymptomatic transmission. In 1918, a person who was infected with the 1918 flu would be asymptomatic for about a day or so. And so they would spread the virus during that first 24 hours. And then they were infectious for another 5 to 7 days after that. This is similar but a little different to the 2020 coronavirus, where asymptomatic transmission happens from 3 to 5 days after the person is infected, but a person can remain infectious for up to 2 weeks, which helps to explain our stay-at-home orders. In both cases, the viruses spread rapidly in urban areas, and in 1918 in military bases and military sites, but we've also seen examples of that in 2020 with high rates of infections on ships that are part of the US Navy. In both cases, sufferers develop ailments in their lungs. And so oftentimes what happens is they develop pneumonia. In 1918, the flu, this Spanish flu, was also sometimes called the Blue Death. And it was labeled the Blue Death because people who were suffering with the flu struggled for oxygen. They could not oxygenate their blood, and they had a blue pallor. In 2020, when the seriously ill develop pneumonia, they often require a ventilator. This machine essentially pushes air into their lungs, and it's a technology that people in 1918 lacked, and many died then, as now, from respiratory failure. So ventilators are probably one of the key differences between the two. I'm going to reference them again later. In 1918, as now, the symptoms were simply terrible. In 1918, this H1N1 virus, the sufferers commonly felt fever, aches, fatigue, sleeplessness, but also depression. Some had particularly severe symptoms. They spit up blood, and this certainly was due to the coughing. Their skin took on a blue tint because they couldn't get enough oxygen. They might have rapid mood swings, and doctors reported hallucinations and disassociation, like they were disassociated from reality. In 2020, the common symptoms are fever, fatigue, and a dry cough. It's a terrible cough. But some sufferers have reported aches and pains, nasal congestion, runny nose, sore throat, diarrhea, and respiratory failure. The thing that I want to point our attention to is the infection rates as well. In 1918, the rate of infection is now impossible for us to calculate precisely. It had a wildly different infection rate depending upon the community. In some places, the infection rate was 0.6 of the population. In other places, it infected 75% of the population. So we can't actually, at this point, look back and calculate the R naught factor. we do know the R naught factor of the coronavirus in 2020. And that's what these illustrations here are intended to help us appreciate. The R naught factor is how many people will one infected person infect. And for the coronavirus, it's 2 to 3. It's about 2.5. So one infected person will infect 2 or 3 other people, compared to the seasonal influenza that's about 1.5, or measles that is the whole community, which is why measles is such a dangerous disease, because of its R naught factor. So we do know the R naught factor of the coronavirus in 2020. But breaking this down into people who become infected, how many of them suffer severely? In both cases, about 80% of people who contract 1918 flu and the 2020 coronavirus experience mild symptoms, and 20% experience severe symptoms. The major difference is the number or percentage of people who die. The sources that I read said up to 16% of people who contracted the 1918 influenza died, where in 2020, and we are still trying to figure out this number, it's somewhere between 0.7 and 1%. I think that this low number is due to the technology that we enjoy today, to the ventilators that can breathe for a person who might otherwise experience respiratory failure, but also to medications that can treat the symptoms and can help a person feel better as they're suffering from this ailment, but also our knowledge of viruses and how viruses act on the body. Even though we don't have a vaccine, we're still figuring out the coronavirus. We do know a lot more about viruses which were entirely unknown in 1918. I want to compare next the populations that are most at risk. Usually the flu is most dangerous to people with weak or underdeveloped immune systems. So this includes children who are developing their immune systems, the immunocompromised, and also older people. In 1918, the flu disproportionately killed young people. Part of the reason for this is that younger people had highly efficient immune systems, and it went after their immune systems, or their immune systems went after the virus. Let me explain. So their bodies released toxins called cytokines to fight the infection. And these cytokines were so strong that they destroyed lung tissue that was also struggling and inflamed by the virus. So an efficient immune system made someone more likely to die from the 1918 flu. Those between the ages of 15 and 45 died at a higher rate than other age groups. In fact, more men than women died, except for pregnant women. They died at a higher rate than women who weren't pregnant. Add to this the context for the war that brought young men into contact and concentrated them into small places, and this produced an ideal environment for the virus to spread. And that's what you see this British health minister noting, that in the midst of perfect health, the first case of influenza would occur, and within the next few hours or days, a large proportion would be stricken down with the same type of febrile illness, that it spread rapidly and in a manner that medical professionals were surprised by. The 2020 coronavirus is different from the 1918 flu and more like a traditional seasonal flu in terms of the populations who are most at risk. It has its greatest impact on the immunocompromised and aged populations. The deaths that resulted from global infection of the 1918 flu were somewhere between 50 and 100 million. And these are terrible numbers. I know that. Estimating the range between 15 and 100 million is a really wide gap. Worldwide, the deaths break down, and these dots don't indicate even that 50 million, but they help to give us an impression of the places that suffered most greatly with the 1918 flu. There were about 675 Americans who died, 675,000 Americans who died in 1918 and 1919. Compare this, though, to India that lost many millions of people. And again, 6 to 15 million is a terribly wide gap to try to describe the casualties from the 1918 flu. The problem with the numbers is the record keeping, that it is impossible for us in 2020 or even in the 20th century to determine what people died of, if they died from the 1918 flu or from some other ailment. Compare this to 2020. As of yesterday, about 3.2 million people in the world had tested positive for the coronavirus. And there are over 230,000 deaths. Comparing these two pandemics, if we were just looking at the United States with its 675,000 people who died, that's about 33,000 people every month. From late January to April of this year, about over 55,000 Americans have died, and more certainly will. But it gives us a sense of proportion between the 1918 flu and the 2020 pandemic. I want to shift now to the responses to the flu. This is one of the things I found most fascinating as I learned about the 1918 flu. It's just how similar our response technology and strategies are. In fact, I think that the best strategies for responding to the pandemic in 1918 are exactly the same ones we're using in 2020. And what I have for you here is a document from the Jesuit House Diary here on the Gonzaga campus from 1918 that David Kingma shared with me, illustrating how the campus was impacted by the 1918 pandemic as members of the community became ill. Despite a century of technical and medical innovation, which have brought us really, really wonderful things, we are in almost exactly the same place as people in the 19-teens as we respond to this virus in 2020. In 1918, Americans tried to prevent infection with social isolation. That's the thing we call it. In 1918, they called it the shutting down of public gathering places. And that's what you see in this headline from the Seattle Times. So they closed down, cities closed down, theaters, bars, libraries, schools, and churches. And what I find fascinating about this comparison is how the shutdown occurred. There was no national order. In fact, the only national leadership came from the US Surgeon General, Rupert Blue. This is something he said in October of 1918. So as that second wave was really ticking up and tens of thousands of Americans were dying, he said, there is no way to put a nationwide closing order into effect, as this is a matter which will be taken up, which is up to the individual communities. In some states, the State Board of Health has the power, but in many others, it's a matter of municipal regulation. And that description right there is how this played out. The US shut down by cities, sometimes with the support of states, but President Wilson did not issue any nationwide directive, and neither did anyone else in the national administration. So I see this as quite a difference from today's quarantine, where state governors have taken charge in determining how to preserve the health of state residents, and they are now also coordinating among regional states in order to respond to this pandemic. In 1918 and 1919, it was city boards of health, with the help of mayors, that shut down public venues and ultimately shut down entire cities. So cities also, in addition to shutting down public venues, they also mandated or advised the wearing of facial coverings or medical masks, which is what you see on the police officers here. This meant public workers like police officers, but also mail carriers and bus drivers had to cover their faces. Also, soldiers had to wear them in cities that mandated face coverings, which is what you see with the American Expeditionary Force here that was marching through downtown Seattle. Some state boards of health circulated instructions on how to make face coverings, and these look remarkably similar to the instructions we've received recently. This quote is from the Iowa State Board of Health, and they describe the face covering, saying the upper margin of the face covering needs to be drawn tightly over the bridge of the nose and right under the eyes. These masks should be washed after each use, not touched once they're tied on, and boiled for 5 minutes before wearing them again. About a month ago, the U.S. Surgeon General, Dr. Jerome Adams, and this Center for Disease Control and Prevention in the U.S., they advised Americans when out in public to wear face coverings. They should fit against your face, and they should not substitute for social distancing. So we've received some of the same instructions that Americans received in 1918. The difference, I think, though, is that Americans in 1918, they clearly used face coverings as a way to avoid shutdowns and distancing themselves from other people. I think that you see it here in this photograph of these young women out on the town. This also happens to be in Seattle, but also in the image that's on the left, where this man has modified his face covering so that he can still smoke his cigarette without removing his mask. People clearly were disobeying these orders. The city of Oakland started to arrest residents who defied the face covering order. The Oakland chief of police said, "We are going to enforce this mask ordinance, even if we have to pack the city jail with people. This epidemic is too serious to be taken as a joke, and the men arrested will find it's no laughing matter when they face police judges for fines for violating the order." In 2018, so this is a couple of years ago before our current pandemic, there were a lot of reflections on the 1918 flu. And many of these reflections noted how important the city closures were. Many stories compared the city of Philadelphia to other cities like St. Louis or Seattle. One Seattle journalist said that the death toll in Seattle would have been much worse if the city, county, and health officials had not taken steps to shut down the city and slow the spread of the virus. Seattle suffered a 0.4% mortality rate as in the city overall as a result of their closing measures. The city of St. Louis did the same thing. 2 weeks after they heard about the virus and before they had their first reported case, the city officials went to shut down all public venues, and the health department supported this. They had a 0.38 mortality rate in St. Louis. After they reopened the city, a few months later, they had a resurgence of cases, so they shut the city down again. Compare this to the city of Philadelphia, where in the fall of 1918, they went ahead with plans for a citywide parade. 200,000 people turned out, and within 4 months, 12,000 members of that city or residents of that city had died, which gave them a 7.2 mortality rate in the fall of 1918 into early 1919. This helps to illustrate to us how the closure of public venues works. It worked in 1918, and we do still need some historic distance from where we are right now, but I suspect we'll also find that these closures have worked to lower our infection rate and our death rate. The differences in the responses to the pandemic in these different cities that helps to highlight the ways that the pandemic tested the American social fabric in 1918. And I think what we find in 1918, but also in 2020, is that the pandemic exposes weaknesses in the social fabric. It highlights American inequality, bigotry, and even inhumanity. But even as the pandemic rends the social fabric of the United States, it also reveals threads that persist and that continue to hold the society together. So I want to look at that now, how I think these pandemics tested the social fabric. In 1918, the most pressing matter in the United States was the First World War and the obligatory patriotism that came with it. The reason why the city of Philadelphia had such high rates of infection and death was that officials decided to proceed with this war bond drive and parade to support American troops. They did this despite advice from doctors in the city that advised them to stop the parade. Newspaper editors even suppressed stories about the flu and kept them out of the paper because they didn't want to worry the public. They didn't worry the public. City officials did nothing to diminish enthusiasm for the parade during a moment in US history when Americans were required and even coerced to be patriots. And they were coerced through this to be patriots through the sedition law and through random stopping of men to make sure they had registered for the draft. But as a result, the city of Philadelphia suffered tremendously for its neglect of public health. In 2020, our political context is polarization and neglect. In terms of polarization, many Americans have become deeply committed to their political camps, and in some cases, they are more committed to party than they are to one another. We see this manifest in responses to the pandemic in several forms. We see it in the panic over the viruses, in the hoarding, the sense of a loss of control, but we have mechanisms to try to protect ourselves through social isolation. We also see it in the impression that the federal government is a greater enemy to the people than the virus itself is. But even the social isolating is politicized in our current climate. We've seen Americans protest against state and local closures, these social isolating measures. Some argue that the closures are an infringement on their liberty, and that is something that government cannot do. But I think if you step back and look at what's going on, what you see is that the quarantine is a public health measure rather than a political act. And as a public health measure, it is similar in many respects to speed laws that we all adhere to seatbelt laws, and to recommended vaccinations. And certainly people will hear me say this and disagree, because we have been conditioned in the present moment to see every act of government as partisan, not as a concerted national effort to combat a human virus, a new human virus. Other political aspects of the US response to the coronavirus is something that I learned by talking to other experts who happen to be just down the hall from me. I asked a couple of colleagues in the political science department for their impressions of the consequence of the pandemic on American politics, and their responses were fascinatingly similar. I asked them, what have you learned about the US or international relations, and what do you think a tentative takeaway from this pandemic might be? Dr. Stacy Tanichev in political science, she said, I expect that the lack of US leadership, both at home and by the federal government, and abroad, is going to alter the global order. And specifically, she noted the villainization of the World Health Organization. This is an organization that the US has, up until now, been deeply invested in. The US has taken a leadership role in the World Health Organization, and the US also benefits from this organization because it helps to contain epidemics and prevent them from becoming pandemics. And so Dr. Tanichev wanted to point out that this is definitely a break with the past. Another colleague noted another break in US foreign policy, and said the thundering lack of US global leadership in responding to this is astounding. It constitutes a rejection of 75 years of US foreign policy that we've paid trillions of dollars to achieve, and the deaths of hundreds of thousands of Americans and millions of others more. This is getting far, far too little attention in the national press. The shape of this pandemic right now would be different if the US was leading a global coordinated response to it. And Dr. Gardner, who made these observations, notes that this is probably part of a larger shift in global leadership, and we see it manifest with really terrible consequences in the present moment as we combat the coronavirus on a global scale. Another way we see similar kinds of fractures between 1918 and 2020 pandemics is in this us versus them mentality. In 1918, Americans and their European allies, they quickly blamed the Germans for the pestilence, and they did this through their war propaganda. It reflected this altered perspective. And the thing to keep in mind is that Europeans, by 1910, Europeans viewed the world in racial terms. And so by 1910, they had classified Germans as Teutons, who were at the top of some seeming fictional racial hierarchy. But the Allies all revised these lofty assessments of Germans during the war. During the war, Germans became Huns, a barely civilized group of people who were a barbaric race. And so that's what you see depicted in these two cartoons. The one in the middle, it depicts a German Hun who is entirely baffled by Wilson's 14 points, his lofty ideas for the war. So he seems very barbaric. The poster on the far right, if you're all looking at this in the same way I am, it is another depiction of German soldiers. And you know that they're German soldiers because of the Pickelhaube helmet that they have that has the little point on it. In that case, the German people, this German soldier, has been entirely reduced to a primate. He is no longer human. And it is using this imagery to try to encourage Americans, in this case, to enlist in the army. This was at play during the pandemic because the propaganda shifted in 1918. And the Germans, these are former Germans who were Huns, now became germ Huns. So they were carriers of disease and pestilence in the propaganda that depicted them as not only no longer human, but they are a pestilence. This is an example I use in my survey course to illustrate just how malleable racial categories are and to show how race has absolutely nothing to do with biology. Even though
activists in society and in academia have struggled valiantly over the past century to put the lie to race classification, racial characterizations, and to racism, the American social fabric failed this test again in 2020. We see how, in the vilification of Asian Americans and even Asians, as somehow carriers of disease, which they are not. The hostility against Asian Americans has little to do with the coronavirus, and it has much to do with the persistent falsehood that Americans have some kind of certain look or specific ethnic origin associated with Europe. This has never, ever been the case in the United States, not since the very beginning of the Republic, but it is a mythology that we have clung to for centuries. This persistent mythology came raging to the fore when the nation encountered fear and uncertainty caused by this pandemic. And this vilification represents a break in our social fabric, one that I think even well-meaning media outlets contribute to without intending to do so. And here I want us to revisit the stories that we've heard about the flu's origin, which appears to be an urban marketplace in the center of China, one that sells fresh vegetables, fish, poultry, and meats. In fact, the US has called on China to close these marketplaces because experts think that the COVID-19 virus originated there. This policy recommendation and some of the reporting have suggested that these markets somehow sell unusual food, and the underlying suggestion is that Chinese markets sell something questionable as food. And that's how the virus spread to humans, which they do not. What we know about the viruses, and as Dr. Andrade explained, is that specific animals can share certain specific viruses with humans. Investigations show that nothing unusual happened in the Wuhan marketplace. And markets like these, by the way, are ubiquitous throughout the world. They're unusual in the United States. So we know that markets are not necessarily dangerous zones of contagion. In fact, humans acquired a zoonotic virus they acquired them from birds, from monkeys, and from swine. And the last pandemic in 2009, the one that was labeled the swine flu, was a zoonotic virus that humans acquired on a Texas pig farm. It spread among farm workers in Texas and California, but officials didn't notice it until it spread to humans in northern Mexico. And initial reports wrongly labeled this the Mexican swine flu when it really had originated in the United States. In fact, just a few weeks ago, a new avian flu emerged in the United States. And this is not a zoonotic. It's not one that humans can currently catch. But it does help me further my point that targeting marketplaces in China for closure is not going to halt viral variation, and it isn't going to stop the spread of zoonotic viruses. In fact, I think that targeting Chinese marketplaces plays into Orientalism, the suggestion that Asian people are somehow strange or unusual or mysterious. And this has everything to do with the history of relationships between Europeans and Asian people. This, I think, is terribly, terribly similar to the wrong-headed scapegoating of ethnically Asian people for the current virus. So, getting to my last point, last example of how the pandemic has tested the social fabric and how it exposes threadbare spots in our society. A few weeks ago, news outlets began reporting appropriately on how infection and death from the coronavirus are disproportionately impacting Americans of color. This story provided details that help to explain why African Americans, Indigenous Americans, Latinas, Latinos, Latinx Americans are suffering with greater infection and higher mortality rates. The reporting pointed to existing weaknesses in our social fabric, to things we know that are there but we struggle to address. Namely, that Americans without health insurance are more likely to be Americans of color. Not having health insurance is indicative of work that either doesn't offer health insurance as a benefit, or that the health insurance is too expensive to afford. And when you don't have health insurance, you avoid the expense of seeing a doctor. So uninsured Americans, as the story pointed out, are more likely to have health problems like asthma or obesity. They're also more likely to have other ailments like diabetes. And Americans with these health problems, they suffer more greatly with the coronavirus. What these numbers tell us is that working Americans and poor Americans, they are at the center of the storm in this pandemic. Working Americans and poor Americans live close together because it's more affordable. They continue to work in essential jobs, while many middle and upper class Americans can shelter in their homes. They get sick and they can't afford it. and they're more likely to suffer severely, which they also can't afford. The way the coronavirus rends our social fabric exposes a class divide among Americans, and the brunt of this pandemic, it applies to them. And this is the same thing that happened in 1918. I'm going to move to 1918. In 1918, as Americans suffered with the flu pandemic, this was a low point of institutional and social racism against African Americans. They suffered with the flu pandemic, and they died at a rate perhaps 2 or 3 times higher than the national average. But perhaps the most glaring example of class divide emerged in Alaskan villages with disproportionate mortality rates. Indigenous Americans have had a much higher mortality rate than Euro Americans. And in fact, with the flu pandemic, their mortality rates ranged from 5% to 35%. In one Alaska village, had an 80% mortality rate because of this flu pandemic. This testifies to the neglect of Indigenous American nations in the early 20th century, something that they continue to struggle with today. So finally, I've related some distressing stories about the 1918 and about 2020. Both viruses struck the points in our society where we are the weakest. And so I want to end by noting the threads that have held, those that are really strong. And you are familiar with these. The societal strength is in the praise and appreciation we demonstrate without reservation in communities singing from their windows. This didn't just happen in Italy, this happened in the United States as well. These people inspire us with the beauty of humanity. We also see this in the uproarious applause for healthcare workers, the praise for grocery store workers, farm workers, and Teamsters who supply us with essentials. By giving them applause, we inspire one another with our resiliency and their resiliency. We also see this in the face mask sewing drives and donations. And here we demonstrate care for all strangers. So this gets me to the lessons. What can we learn from this comparison? What we learn is that viruses are resilient. The pandemic will return in waves. It may or may not shift, mutate, or drift, but probably one of these things will happen. We enjoy new advantages in medicine, but the best defense that we have against the pandemic is the same thing they had in 1918, little to no contact. An epidemic and pandemic test government and society. They expose our weaknesses, but also our strengths. And the best way that we can respond are to scrutinize polarizations. At least we should be aware of them. We should trust experts. We should collaborate on problems, which is what I aspire to do with this presentation by turning to experts who are all around me and by bringing together all these areas of inquiry in the sciences, social sciences, and humanities. And I think that we should focus on the strongest threads, to hold tight to these threads so that they don't fade along with the pandemic. So the first question, are there historical records of German Americans facing discrimination in their everyday lives related to the Spanish flu in the same way that Asian Americans are facing discrimination now? German Americans in the United States, or German immigrants, were absolutely facing a lot of repression, but that started in 1914, even before the US entered the Second World War. There was an uptick starting in 1917 when the US entered the First World War. There was a real, this coerced patriotism that I described, that was mobilized against Germans in the United States. And at that point, there were many thousands of first-generation German immigrants. There were also German communities, German-speaking communities, and all of these faced pushback. The one I'm most familiar with is that Montana passed its own sedition law that made the speaking of German unpatriotic, and there were individuals hired in the state to try to set up German immigrants for prosecution under that sedition law. I don't have a specific example of how Americans responded to German immigrants and German Americans when the flu pandemic began, but I suspect there is evidence out there of this. Yeah. Oh yeah, there is a question about why there was no information from South America on that map of the casualty rates, people who died from the 1918 flu. and I just don't have the evidence. I don't have the material, but it absolutely spread to South America, and there were South Americans who died as a result of the flu pandemic. So it is there. It is an effort that requires a lot of historic digging in order to figure out who had the flu and what they died from.
There's one more question, Vita, if you have time to answer it.
Oh yeah, absolutely.
John Carlson asks, was there an animal host for the virus implicated in the 1918 pandemic?
Possibly. The things that I read about the 1918 virus, they suggest they don't have a culprit. They do know that it began in Kansas. So when I was talking to Dr. Andrade about viruses, she suggested it is possible that it was a zoonotic, that it came from an animal host. But the problem is that there are only 5 samples of the 1918 flu virus in the contemporary US. So if virologists want to study the 1918 flu, they only have 5 pieces of it. And trying to trace back where it came from is really, really challenging. It wasn't until the 1990s that someone took one of these samples and deconstructed its DNA. And so it was in the 1990s that they realized it was an H1N1 virus and possibly the first one in the human population. And so because of these really small pieces of evidence, it makes it hard to say that it absolutely came from an animal host, but that is a possibility. Yeah.
Vita, would you like to take Andy Goldman's question? I'll read it. In
Okay.
terms of the problems currently encountered by minority communities, those which you spoke about, do we see similar higher casualty rates in 1918, 1919 in communities of color?
Yeah, the scholarship that I've read suggests that yes, the casualty rates among communities of color in the United States was higher than the national average and the average among Euro Americans. And so with African Americans, the mortality rate was around 2 or 3 times higher. In indigenous communities like the ones I mentioned in Alaska, it was far higher. Other statistics out from elsewhere in the world, in New Zealand, the mortality rate among white New Zealanders was about 1% or less. The mortality rate among the Maori, the indigenous people of New Zealand, was 4%. So in that case, it was 4 times higher. So this is the case not just in the United States, but in other parts of the world where the mortality rate was higher among Americans of color and among indigenous populations elsewhere in the world. Yeah, it's a great question.
I think we might have time for one more question if you're willing to take it. I
Yeah,
can read
absolutely.
Stacy
If there are
Tunning-Chev's. Sure. Stacy Tunning-Chev from the Political Science Department asks, was there more trust in experts in 1918 than there is currently? You mentioned that some people didn't wear the masks or take it seriously, but was there any organized pushback, such as we see with the protests against the shutdown today?
I did not see any evidence of organized pushback against these citywide quarantine orders. And it was sometimes disconstruing, I guess, for people who were traveling. There's an account of a woman who traveled from Chicago to Los Angeles. And when she left Chicago, there was no quarantine order. When she got to Los Angeles, there was a quarantine order and a mask order. And so she got off the train and she saw all these people in masks. And so because the policy varied by city, that meant that you were dealing with a different response in all these different cities, rather than what we have now, which is states giving this order, so that in the case of Washington State, it's a statewide stay-at-home order, and the governor has endorsed this face covering mandate. Maybe it's not a mandate, a recommendation. And so I didn't see in the evidence from 1919 coordinated efforts to try to push back. I think that it was more individual, like the evidence from the city of Oakland, where the police chief was enforcing a mandate on face coverings and arresting people who defied the face coverings. It was interesting too that his quote said, "These men." So most of the people he was arresting were men who were defying the face covering order. Before we wrap up entirely, because this is the end of spring semester 2020, the last day of classes, I want to wish all the students, not just at Gonzaga, but elsewhere, a lot of luck to you all as you finish up the term. I also want to compliment all the staff and faculty who have kept us going through our quarantine, and wish you all a wonderful, rejuvenating summer. Thank you everyone for joining us. We really appreciate it. And if you have questions down the road, you can find me on the department webpage and email them to me.